So carbohydrates, you can refer back to your mind map. Okay, just go through the mind map. So make sure that you complete your mind map. So classes, mono, disaccharides, polysaccharides, mono, simple sugar. I'm going to go very fast because we have learned this before. Disaccharides, double sugars. Example of disaccharides like maltose. Remember maltose, glucose and glucose. Another one, sucrose, glucose plus fructose. The difference between this maltose and sucrose is in terms of the linkage. The linkage for maltose is 1,4, alpha 1,4 glycosidic linkage, and for sucrose is alpha 1,2 glycosidic linkages. So different in terms of the linkages. Polysaccharides, monomers of glucose, hundreds of glucose attached or joined together to become a macromolecules or a polymer. And then the functional groups that you have to remember for glucose. There are two functional groups. As I said, functional groups are important to identify macromolecules. So for glucose, we have two functional groups, C double bond O, which is carbonyl. Another one is hydroxyl group. Okay, next, another important thing that you have to remember, we have two types of sugar. One is aldose sugar, another one is ketose sugar. Aldose sugar, example is glucose, whereby the carbonyl group is located at carbon number 1. Ketose sugar, example like fructose. I'm going to concentrate on the important sugars, for example, like glucose and fructose, because we're normally going to use all these types of sugar. Okay, for ketose, example is fructose, and the functional group, the carbonyl group, is located at carbon number 2. So the location of carbonyl group actually determines what type of sugar, whether it's aldose or ketose. All right, next. Okay, so far, are you following me?
Yes, madam.
Yes, madam.
All right. Okay, because this one is just a recap, so I'm going to go very fast. Okay, then we differentiate between the alpha and beta glucose ring structures. Remember, ring or cyclic structures when it's in aqueous solution. So they're going to be in this form. So alpha glucose, we look at the functional group, hydroxyl OH, and the location of it. For alpha, it's located below the planar structure of glucose. For beta, it's located above the structure. So there's the difference between the alpha and beta glucose ring structures. Okay, so remember that. And then we have learned on the processes. Condensation dehydration is a process whereby a bigger molecule is formed from the short monomers. Okay, bigger molecules from short monomers via the eliminations of the water. So you're going to have a synthesis of bigger molecules from a short monomers. This is what we call as dehydrations or condensation. So from bigger molecules to smaller molecules, the process is hydrolysis. And the linkage for the carbohydrate is glycosidic linkage. Okay, glycosidic linkage, we can call it as a glycosidic bond. So you can look at the function. Okay, I've gone through this. Okay, take a look again on the figures, how the water is eliminated. So this water is removed so that the bond is formed. Yeah, so water removed, alpha 1,4 glycosidic linkages are formed for maltose. For this reaction between glucose and fructose, water is removed, then alpha 1,2 glycosidic linkage is formed after the elimination of water. And then polysaccharides.